Does everybody have one of these? It's got this on the back. This. Okay. Let's do that and real quick while I'm thinking about it. Don't worry about the foci. We didn't really talk much about the foci. Doesn't really come up much in this book. It'll be in your pre-calc if you take pre-calc. If you don't take pre-calc, you'll never know. Too bad. So let's do the first question for each one. Do you see a hyperbola up there somewhere? Yeah, the second one. Why the second one is? Yeah, I've got the y squared, x squared on the same side, and there's a minus between them. There's a subtraction. I like it. One of them's negative. So that's going to be a hyperbola. Is there a circle? Yes. Which one? Which one's a circle? The third one, circle. Now you could divide by 9. We actually did that. We treated it as if it was an ellipse. Because it is an ellipse. It's an ellipse where you go the same amount in each direction. So we call that one a circle. Sort of like a square is a rectangle. It's just a special square. A special rectangle, right? You give it a different name. And of course this guy is going to be the ellipse. You can't multiply by one number and give yourself a radius because the radius changes as you turn. You know, not as much and then more, then not as much maybe, so to get a nice UFO shape. Now to be honest, once you identify, you might as well just graph it and then you can answer these questions much easier. The center you should kind of know. Which is the only one whose center is not 0, 0? Which one? Yeah, the circle. How can you tell? It's shifted. There's numbers inside with the x and the y. It's been shifted. These guys, there's no number inside with the y. It's just y squared. There's no plus 1, minus 3. So both of these guys have a center of 0, 0. This guy has a center of what?
Negative 2, 1.
Negative 2, 1. He can z-ass it. I like it. This guy's only got one more question. Let's answer him real quick. What's this guy's radius?
3.
Yeah, because it's x stuff squared plus y stuff squared equals r squared. So whatever this number is, it's the square of the radius. Remember, that's just Pythagorean theorem. Just make a squared, b squared, c squared, make it x squared, y squared, r squared instead. Pythagorean theorem. So the radius here is 3. All right. Now, for this guy or this ellipse, except for my row, I know you guys know this. Other people chance. How far do I go out on the x-axis? 3. So here I go up 3. Right 3. Left 3. And how far do I go on the y-axis? 5. So up 5. Down 5. Now, if this was a hyperbola, one of those pairs I would not have filled in. It wouldn't be a real point. I would make my little rectangle. It would be outside the rectangle instead of inside the rectangle. That's the beautiful connection between those two. This is an ellipse, not a hyperbola, so it's going to be inside. Oh my God. My ellipse has the mumps. Something's wrong with it. Had a rough child. Leave it alone. So now, what is the length on the x-axis? 6. How long is it on the y-axis? 10. Good. Just double the 3 and the 5, because that's how far you go out in both directions. So of course you end up being double that total. All right. So this hyperbola I would do the exact same way. Now, which axis does it sit on? Does it actually touch? The y one, because it's the one that's positive. It's allowed to have y intercepts. What's underneath this x squared? Good. So how far on the x-axis am I going to go? That's crazy. Square root of 1 is 1, so I'm going to go 1, 1. Now it sits on the y-axis, Jeff, so I should put like a little x here, a little x here. Put a little point there. How far on the y-axis do I go? 4. I like it. So I go up 4. Now that's an actual point. Down 4. If the center was different, I would just start counting from the center. I go 4 up, 4 down from the center. It's the only difference. Now what do I do with all these little freaks? If it was a plus in the middle, it would just be this really skinny, tall ellipse, right? But it's a minus, so it's going to be the opposite of this. It's going to be, in this case, it's going to be out like this. So I'm going to make what here? A little box. And then through the corner, so this is kind of nice. This is so you have to get a few more tools to be able to fully analyze this. There's the idea of a limit. As you let something get really big, what does it do? And that's really what an asymptote is what does it do eventually? What does it look like it's going to do? So when I draw these lines through the corners, they are my asymptotes. They are the walls that I'm going to follow. My God, Jim. So critical of yourself. Well, yeah, you're doing a shit job. Okay. So there's my little, you take them out far enough so you can follow them. So now just follow them. Woo-ha! Woo-ha! All right. I don't restrict what sound effect you want to make. And finally, the easiest one, hopefully. Well, the ellipse is really nice. Circle's even nicer because you just go the same amount everywhere. Where's the center? Negative 2, 1. So negative 2, 1. There's my center. And from that point, I'm going to go out 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then you try to make a circle. Some of you guys will be better than me. That's not too bad for me. You see Charlie Brown. I like him. Okay, so obviously, well, not so obvious, but there's a lot more you can talk about each of these. There's the eccentricity of an ellipse, which talks about how far away from a circle is it. There are the asymptotes, and what do they really mean, and why are they there, right? And then there's shifting stuff. We're not going to really shift these guys. I mean, well, this guy or this guy. We're not going to shift those because it's freaky enough already. I'm not going to give you a shifted one. Circles, yeah, you can shift those around. We've looked at those before. Where are the vertices for the hyperbola? Yeah, 0, 4, 0, negative 4. Not these, because these are not points on the graph. So 0, negative 4, and 0, 4. If it was on the x-axis, it would have been 1, 0, and negative 1, 0. I like it. So relative to some other stuff you've done, that's nice. Now this might be your personal example of other stuff. Might be on the back. I don't know. Some of you guys realize this one here is easy. I have no qualm saying that because you should all know how to work functions, and these are just functions. N is what I'm going to let be things. So the first term, what's the symbol for the first term? What's the symbol for the first term? A, 1. It's amazing. So for the first term, I just let N be 1. So it really is. It's the equivalent of saying like A of N is 1 over N. What's A of 1? We just don't use that exact function notation for sequences. It's a different choice of how to represent things. Go with it. And I just keep going. A2, amazingly enough, will be 1 over 2. It's amazing. A3 is 1 over 3. A4 is 8. No, A4 is 1 over 4. Let's see if anybody's listening. I mean, so each of these are exactly the same way. So part B, you just put a 1 in for n at first, so you get 1 over 4. Put a 2 in, 2 over 5. Put a 3 in, I get 3 over 6, which is 1/2. And I put a 4 in, I get 4 over 7. Nothing amazing there, right? I mean, it's just plugging stuff in. That's it. This one is nifty. Let me see if you guys can get the pattern just by looking at what we get. So A1 would be 1 minus 1/2, right? When you put a 1 here, negative 1/2 to the first power is negative 1/2. So it's 1 minus 1/2, I get 1/2. A2 is 1 plus negative 1/2 squared. What's negative 1/2 squared?
1.
Negative 1/2 squared. 1/4. So I get 1 1/4. A3, what's negative 1/2 cubed? You guys can do it. What's 1 cubed? 1. What's 2 cubed? 8. So it'll be negative 1/8. 1 minus 1/8 is? You guys are better than this. What's a whole? If I have 8 gallons to fill up my tank.
7 over 8.
Yeah, if I have 8 gallons to fill up my tank, a whole tank is 8 out of 8 gallons. So if I lose 1/8 of a gallon on a trip, now I'm at 7/8 of a gallon. It's not that big of a deal to subtract 1 minus a fraction. Not a big deal. 1 minus 1/8 is the other 7/8. That's all it is. And A4 would be 1 plus negative 1/2 to the 4th power. The negative dies. And what's 2 to the 4th power? 16. So it's 1 over 16. So it'll be 1 and 1/16. Now this is, let me see if you guys can see this one. This is kind of neat. So when I put a 1 in, I get 1/2. When I put a 2 in, I got 1 1/4. When I put a 3 in, I get 7/8. When I put a 4 in, I get 1 1/16. So as n gets really, really big, the result should approach 1. That's the idea of a limit. The limit as n goes to infinity. If I let n get frickin' big, then the result of this is going to go to 1. Because what is 1/2 to the really big? Really small. Really small plus 1 is basically 1. So the limit of this is 1. Okay, now everything I just said about limits and letting n get big, that's beyond us. Not really, but I just told you about it. But it's not going to be able to find. Let me say it out. It will be something you look at more extensively in pre-calc, and if anybody's got to take calculus, it will rule your life for the first half of the semester, and then come back every now and again. Something to look forward to. All right. So all this shit right here was just extra stuff I did, okay? This is all you had to do for this problem, was get the first 4 terms. I like it. Now this was the hardship. This is always more difficult. This is saying, well, somebody got 1, 4, 7, 10 for the first 4 terms. What was their function that they were working with? That's going to be harder.
S plus 3.
It can't be that. If we think it's n plus 3, let's try it. A1 would be 1 plus 3 is 4. Oops. A2 would be 2 plus 3 is 5. Do you see how if it's n plus something, it's only going to go up by 1. Every time n goes up by 1, this is going to go up by 1. But how much do these go up by? 3. So I'm going to need 3n. So let me do it 2 ways. A1 is 1. And what is the basic idea of the sequence? I just keep adding 3. So A2 is 1 plus 3, right? It's just capturing what I just said. A3 would be 1 plus, no, come on. 1 plus how many 3's? To get to the third one, I got to take how many steps?
6.
1 plus 6, which is 2 3's. So the main pattern of the sequence is that I keep adding 3. So if I stop and I rewrite each element using that fact, I can see the pattern algebraically. And you're all like, you just said blah, 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 blah. So I write each one using the fact that every time I get away from the first one, I'm going to add a 3. If I get another step, I'm going to add 2 3's. So to get to A4, how many 3's am I going to add? 3 3's. And look at this. To get to A1, how many steps do I have to take if I start there? How many steps do I take? None. 0 3's. This is 1 3. So for A1, it's 1 plus 0 times 3. For A2, it's 1 plus 1 times 3. For A3, it's 1 plus 2 times 3. So for AN, it's 1 plus A4, it was 1 plus 3 times 3. AN is going to be 1 plus n minus 1 times 3. It's always 1 less. Stay with me. This is just the first of 2 ways I'm going to show you. You might like the second way better. Personally, I like the second way better. So this becomes 3n minus 3 plus 1 is 3n minus 2. Now, another way to do this is to go, I keep adding 3, so I know there's going to be a 3n. Now, stay with me now. I keep adding 3. So every step I take, it increases by 3, right? That's what 3 times n means. Every time n increases by 1, the output increases by 3. Does that make sense? Because that's the exact idea of slope. Now, if I just stop there, A1 is 3. When I plug a 1 in, I get 3. But it's supposed to be 1. So what am I going to do to this to correct for that? I'm going to subtract 2 from it. Holy shit, same thing we just got. Right? So this is the kind of construction way. And this is just the reason it out. I always prefer this way more, and some of my teachers are like, are you scared of that? No, I can do this shit. This is just quicker. Leave me alone. So you can do either way you like. And you're all like, is there a third way? These are easier, believe it or not. This one looks like these, don't it? Or don't they? I don't know, grammar me not much. So it should look like this. It's a ratio, right? So does the top start at 1, like n does? No, it starts at 3. So to make the top, what do I do to n? If it starts at 1, I'm supposed to have a 3. I'm going to add 2 to it. The bottom's supposed to start at 4, n starts at 1, so the bottom I'm going to add... And I know this is good because every time I go up by 1, the top and bottom go up by 1. So that is exactly like this. Notice the bottoms up here, 4, 5, 6, 7, are the exact same as the bottoms here. What was the bottom here? N plus 3. N plus 3. That might be why I put them on top of each other. Now this one, now, sometimes they give you one, I just want you to realize what you're allowed to think about. What's the flexibility? Can you guys just step back out of everything and just say, how do the top and bottom relate each time? How is the top related to the bottom in every one of these? It's always 1 less. That's it. So if I can figure out what the bottom looks like, the top will be that minus 1. Can you guys just see that fact? Right, so that's where, when you're first learning this stuff, you don't realize that that's a part of the problem, is to just kind of look at it. Because you're all like this, well, let me see, and no. All right, the top is 1 less than the bottom. It tells me I'm going to start with the freaking bottom. Because once I get that, I can just do the top minus 1. Well, what's the idea of the bottom? Yeah, it keeps multiplying by another 2. 2 times 1 is 2. So 1, 2 is 2. 2 times 2 is 4, which is 2 squared. 2 times 2 times 2 is 8, which is 2 cubed. So this looks like 2 to the first, 2 squared, 2 cubed. So when n is 1, the bottom is 2 to the first. When n is 2, the bottom is 2 squared. N is 3, 2 cubed. So when n is n, the bottom is 2 to the n. You guys see that? When n is 1, it's 2 to the first. When n is 2, it's 2 squared. So whatever the hell n is 2 to the that. So the bottom is 2 to the n. So what's the top got to be, based on what we just observed? 2 to the n minus frickin' 1. Because the top is always 1 less than the bottom. To be honest, you could have done the same thing here. Look, the top, isn't the top always 1 less than the bottom? So if you notice the bottom is the same, n plus 3, you subtract 1 from that, n plus frickin' 2. So, I mean, if that would have worked there too. Okay. So some of this is just showing you what is it that I'm allowed to think of. So when you see a problem like this, you're like, what am I supposed to do? What am I allowed to try? Anything, right? And you look at what's the general. Is there something generally I can see, or do I have to start with like specifics? Okay, all right. And here's that last thing that we introduced. Sigma notation. Do you remember if I actually said that word? Sigma, it's the Greek letter sigma. This guy. And like anything, like logarithm, like anything, you just have to understand what the symbol is asking you. So for example, all the symbol is asking me is add up k squared if k goes from 1 to 4. So if k is 1, you get 1 squared. If k is 2, you get 2 squared. So forth, and then you just add them up. That's crazy. So the big Greek letter S stands for sum up these things. This is specific terms in a sequence. They would be separated by commas. This means add up the first whatever, or this through this term. Add those up. So if I had this staring me in the face like we do, what's I go from to? I goes from 4 to 6. So what's the first thing I get? And then add it to, and then add that to. So now it just becomes getting an LCD. What's the LCD between 4 and 6? No. Here's a trick. What if 4 and 6 share? A factor of 2. Right? Stay with me now, guys. Come on. Stay with me. 4 and 6 share a factor of 2. What's 4 times 6? 24. Divided by the 2 they share is 12. That's the actual lowest CD, common denominator. 24 is a common denominator, not the lowest common denominator. All right, Jason. So 4 and 6 have an LCD of 12, and they need a 5. 12 times 5 is 60. So the LCD is 60. You can also do this. 2 times 2, 5, 2 times 3, and you can tell what each one needs. This one needs a 5 and another 2. What's 6 times 10? 60. All right. Right? So the LCD is just going to be 60. This guy needs 2 2s and a 3. And this guy needs a 3 and a 5. So I get 15 60ths plus 12 60ths plus 10 60ths is 37 60ths. So someday people will stop cringing just because there's fractions in a problem. Someday. Okay. So, what I've got now, I changed my mind about something earlier. I want to give this to you now, and what we'll do is, I want you guys to start working on this. Now, if you want to, at the same time, if you have questions from the practice final, you can start asking them also. If you don't want to look at this. We're going to look at this in the lab. And we can also talk about the practice final. We can talk about corrections, whatever. Let me give you a copy of this here. Now, if you did not get a practice final, yeah, bad. Come to the lab. No, if you come up and ask me nicely, I might give you one. The lab has. So I'm kind of making it a little bit wide open. I've got certain things I want to say about this. I'll talk about it in lab tomorrow, today and tomorrow. The practice final, you can look at that if you want to. I'm going to have the answer key for that tomorrow. Okay. I'm trying to make this as productive as possible. I am. So I'm giving you a lot of stuff to pull questions from. Yes? Yeah. Everybody, yeah. Why don't we go ahead. You started doing this, maybe take a second and try to do 1D real quick. 1D on this handout you just got. Try out 1D. You guys see the similarities amongst every problem in one? They all have 7 minus 3x stuck somewhere, so they all have the exact same first step. In fact, in general, it's always get the thing with your x in it by itself first, because then we can attack that directly. Just make sure everybody's on the right track. What's the first step? Oh, yeah, I got that, Chuck. When you have a log equals a number, you just have one thing on each side, you can always use the basic idea of logs. What is the basic idea of this log? What's it saying? Why is log base 2 of this 4? Because 2 to the 4th is 7 minus 3x. That has to be, if this is true, then that has to be true. And now I can solve what x must be to make that work. Yes. I mean, for most of these, you should get a fraction somewhere. But you should get 2 answers, right? Okay. What do you get over here? I mean, 2 to the 4th is 16. Subtract 7, I like it. 9. Divided by negative 3. And is that okay? Yes?
No.
Yes. Because when I plug in negative 3 and I get 7 minus 3 times negative 3, 7 plus 9 is 16. I don't get it 0 or negative, so it's allowed. I will allow. So every single one of these has the same first step. Subtract 1. If you square this, you can't say, I don't want to square him. He doesn't have to be squared. So I'm just going to square this. You don't have that kind of power. Stop it. You have to square the whole side. And why the hell would you want to do that? Make this one term so I don't have to FOIL out the radical shit. I don't like to FOIL radical shit when I have 2 radicals in the equation. Then I can't escape doing that. That sounded... Aw, okay, sorry. She's right. Most of them were salvageable. It was fruit. So again, I want to make sure everybody heard me about this. Because I decided to be nice. If you didn't get a copy, we'll practice file. You can come up and ask me. Think about giving you one. You'll undoubtedly notice that the practice final is really, really long. The actual test will be longer than a normal test. It'll be, I have twice as much time, right? The final exam is going to be 2 hours. So we normally have like 55 minutes. I'm not going to go crazy with that though, no matter what you think. If you didn't get this handout here, it has my schedule for next week. I am giving finals the following Monday, but if you haven't got your questions answered by Friday, so we're going to take the final on Tuesday. Next Monday's a holiday. There's a time we're taking it, so I'll be in my office before that. And if you need to talk to me about whatever, you can email me after the final. I can tell you how it came out. And if you have questions, you can come see me during office hours. So I give a final on the first day and 2 finals on the last day of finals. Yeah, it's awesome. Cool. Huh?
Is that the window? Oh, yeah. Thank you.
Sure. Notice this last problem real quick. There's at least one problem like that in the homework. We'll do this in lab. I've got some extra calculators. But you basically just graph one side, you graph the other side, and you look for where they meet. Is there any way to do this by hand? Can you guys imagine starting to solve this by hand? If you square both sides, then you've made your x stuff trapped in a square. If you subtract these and raise both sides to the e, you've trapped everything up in the power. There's just no way to get x by itself by hand. The only way to solve this is numerically, is what it's called. Using a calculator to estimate.
So, is that right?
Yeah. There's one thing not quite right. Oh, okay, you're fine. Okay. Yeah, and then you just find out where the intersection. So if you hit second trace. So guys, before I forget, in my math lab they have, in the little menu they have something called study plan. So if you click on that, you can actually have my math lab create little quizzes for you from any section in any chapter. And it won't count against your grade at all. And it'll tell you if it's right or wrong. It'll be a nice quick way to review. If you're basically done with homework, that's something else you could do to get ready for the final. In general, what do you guys, so I should have said something about this a lot earlier, but it just occurred to me. When I'm walking up and down in the lab, hopefully you guys understand, I'm not policing you. I'm looking to see if people have questions, right? I have this weird feeling that people are like, oh shit, here he comes, I better look like I'm busy. If you need to work on history homework and you're in there, go ahead, I don't care. If you want to use that time in that way, great. But I'm walking around seeing if anybody has questions. So you have me one-on-one, which isn't always the easiest thing to get. We should really probably use that appropriately.
pretty good right there. I'll see some of you guys in lab.
Okay.